Good morning to one and all. In the last class, we have discussed about some of the addition reactions, addition of ammonia and its derivatives, and that table I have given. You have to complete, and I hope you have completed those reactions with taking aldehydes and ketones as well, the examples. After that, we have discussed one more reaction. That reaction is important, called as reduction. There are two important reduction reactions. One is said to be Clemenson's reduction. Clemenson's reduction, aldehydes or ketones you have to use. The reducing agent is zinc amalgam and concentrated HCl. There we have got alkanes or hydrocarbons. In a similar way, one more reaction that is said to be Wolff-Kishner reduction. Wolff-Kishner reduction. This Wolff-Kishner reduction, general reaction I have represented here is aldehyde or ketone. The reagents used are NH2, NH2 meaning is hydrazine, and using hydrazine there is elimination of one molecule of water and there is an intermediate hydrazone. After that it reacts with KOH. Media is said to be ethylene glycol and little heat is required. There finally we have got the product called as hydrocarbons or alkanes with the liberation of nitrogen. The reaction, oral reaction is said to be very important. You can take various examples of aldehydes and ketones, formaldehyde, acetaldehyde, acetone, like that. You have to use and practice this reaction. Okay, simple reaction. Come to know how the reaction is carried out with various steps. Definitely first step, we all know that there is elimination of water and the product is said to be C double bond N NH2. NH2 is represented in this way, that is H and this is H. Now I will take KOH as the base. OH minus that withdraws a proton from NH2. Now it becomes H2O, and what remains I have represented here, carbon double bond N, carbon double bond N, single bond N minus. Why it is minus? Because the hydrogen it gives one electron and the nitrogen it has one bonded electron. Therefore this complete bond is nothing but minus and remaining is one hydrogen as it is. Okay. Now this is a minus, single bond, double bond. What happens here? Some resonance is taking place. This minus is said to be in between nitrogen, that means a bond between nitrogen and nitrogen, and this pi bond is said to be on carbon. Now it becomes C minus C. C minus, it is not C, C minus N. Okay, C minus N, double bond N, it has lost that minus, means it becomes a plus, and H is there, that H I have already represented here. Okay, now again this intermediate takes OH minus, it withdraws proton from this NH. Now this nitrogen is got an electron, therefore this nitrogen becomes a minus. Now I will represent that charge in this case N minus. Okay, plus charge gone, now it becomes minus or neutralizes. You can say that N double bond N, and this is minus, C single bond N, and this is minus. Definitely there undergoes reaction. Definitely this reaction is carried out in aqueous media, hence proton is there, therefore H plus, it easily attacks on C minus, or C minus is bonded to hydrogen, because these are said to be good friends rather than hydrogen and nitrogen. Now the product formed is said to be, it loses minus sign, that is C only, and attaches to hydrogen, that is H. Remaining is N. Double bond N minus as it is. Now there is due to bond dissociation enthalpy is elimination of N. N means N2 is liberated, and further it undergoes hydrolysis. In that hydrolysis what happens? If it loses N, this carbon got minus sign here. That means C minus. Therefore, again it undergoes hydrolysis. H plus is 2 best friend to carbon. Therefore, bonded to carbon, it becomes CH as it is. And this H is 2 CH. Therefore, this product is said to be hydrocarbon. Or you can say that it is said to be a alkane. Like that, this mechanism is carried out. In detail, I have also given to the notes. You have to refer that notes also. And in the same way, we have discussed two important reduction reactions. Very important. You have to practice 10 times, 20 times until your examination will finish. If you again want to take chemistry interested students, forever you have to remember such reactions. Come to know next, oxidation. Like reduction, oxidation reaction is there. Now I will explain that oxidation very clearly. How the oxidation is taking place. Generally we all know that alcohols undergoes oxidation giving aldehydes. Aldehydes undergoes oxidation giving carboxylic acids. The well-known oxidizing agents are said to be KMnO4 or K2Cr2O7 or chromic acid H2CrO4 and so on. Many of the oxidizing agents. Definitely they are nothing but common oxidizing and good strong oxidizing agents. Aldehydes, they are said to be undergoing easy oxidation in such cases, whereas ketones, they are said to be showing less oxidation towards such reagents, and they are needed some vigorous conditions. Under vigorous conditions, ketones, these are undergoing oxidation. What do you mean? The term vigorous means some high temperature and oxidizing agents are said to be strong, as well as pressure is used. Some conditions are there, more conditions are there. Okay, so I will take an example. That example is said to be the ketone like R, C, H2, C double bond O, next is CH2 and R. If suppose it undergoes oxidation, means addition of oxygen, I will break the bond between carbon 1 and 2. Carbon 1 and 2. What is the possible product here? R COOH plus RCOOH plus, remaining is R CH2COOH. Now this is the main our product. What happens here? The bond is cleavage between carbon 1 and 2. There are 2 carbons involved. But the product, what we have got? Only 1 carbon. Therefore, whenever ketones undergoes oxidation, the product formed is said to be 1 carbon less. 1 carbon less than the reactant taken. Reactant used. Okay. reactant ಯಾವ್ದು ತಗೊಂಡಿವಿ between 1 and 2 carbon. If there undergoes cleavage, it is not forming RCH2COOH. It is simply forming RCOOH. Hence, always you have to remember that ketones when undergoes oxidation, there the product formed is said to be carbon less than the reactant. One carbon less than the reactant. Okay, so like that, ketones oxidation is said to be less important compared to aldehydes. Therefore, you can say that on the reaction reactivity of aldehydes and ketones, if you compare, aldehydes are said to be more reactive than ketones. There are two factors why the aldehydes are more reactive. One is said to be steric factor. Steric factor. What is this meaning? Ketones are having bulky group. Hence, disturbance is taking place, therefore less reactive. Whereas aldehydes, there it contains one hydrogen. Therefore, this hydrogen is said to be somewhat reactive than this R. Adukka aldehydes are said to be undergoing oxidation. And one more effect is said to be electronic effect. Why aldehydes are said to be electronic effect? Aldehydes are said to be more reactive than ketones. This is because of electronic effect. Again, I will take the ketones. They are having bulky groups. These bulky group reduces the charge on you can say that carbon. Other salvagi ಅದರದ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಸಿಟಿ C+ ಬರ್ತಕ್ಕಂಥದ್ದು ಏನಾಗ್ತೈತಿ ಅಂತಂದ್ರೆ ಇದರ ಕ್ಯಾರೆಕ್ಟರ್ ಅನ್ನು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೈತಿ ಬಿಕಾಸ್ ಆಫ್ ದೀಸ್ ಬಲ್ಕಿ ಗ್ರೂಪ್ಸ್ rather than this hydrogen. If this hydrogen, it is more reactive, hence it is said to be there is a easy way to obtain charge or electrophilicity on this carbon. Hence, the two important reasons why aldehydes are said to be more reactive than ketones. Other salvagi, aldehydes are showing oxidation with mild oxidizing agents. Aldehydes are showing oxidation with even mild oxidation also. Even mild oxidizing agent. Mild oxidizing agent. Mild oxidizing agent means not strong. So, which are those? I will take one mild oxidizing agent that is said to be, you can say that Tollens reagent. First one is said to be Tollens reagent. Aldehydes, they are undergoing oxidation with mild oxidizing agent. First one is Tollens reagent. Name is Tollens reagent test for aldehydes. Tollens reagent test for aldehydes. Okay, or it is also known as silver mirror test. Silver mirror test. What is this Tollens reagent? First you have to know that freshly prepared ammoniacal silver nitrate solution is known as Tollens reagent. Freshly prepared ammoniacal silver nitrate solution is known as Tollens reagent. Let the reaction is AgNO3 plus ammonium hydroxide, AgOH plus NH4NO3, AgOH plus NH4NO3. Now AgOH plus 2NH4OH, it combines giving that Tollens reagent AgNH3 twice plus OH minus. This is said to be a complex, soluble complex. Here its oxidation state is said to be 0 and only the silver is said to be Ag plus. Okay. Now this complete formula is known as Tollens reagent. Yes. How this Tollens reagent oxidizes aldehydes to carboxylic acids? Let I will represent. Generally, you can take the formula as aldehydes are H C double bond O. You have to take particularly aldehydes only, not ketones. Therefore, it is C double bond O, RH plus. Tollens reagent is AgNH3 2 times, and this is said to be plus. For balancing, I will take here it is 2 and plus 3 OH minus. For balancing, I have taken here it is 3 OH minus. Now, the product formed is said to be R C double bond O minus. That means aldehyde is converted into carboxylic acid. Minus, it indicates there is loss of hydrogen. Plus, remaining is said to be 2Az. This is very important, known as black ppt or silver mirror. Silver mirror. Black ppt of silver or silver mirror. Plus, remaining is said to be, now to take 2NH3 and remaining is 3H2O. This is one overall reaction for Tollens reagent test. One overall reaction for Tollens reagent test for balancing, that is 4NH3. It is not 2NH3 because it is 4. Now that water is only 2. You have to balance later. Okay. How can you represent Tollens reagent test? Take an aldehyde. Tollens reagent is AgNO3 twice plus and OH minus is, I have taken for balancing, it is 3 minus. Aldehyde oxidizes to carboxylic acid and silver Ag plus is reduced to Az. Az plus is reduced to Az. Okay. Reduced meaning is it takes electron. Addition of electron is reduced, or that is reduction. Okay. Now this is Az plus to Az and remaining all are balanced. Now how the mechanism is taking place or reaction mechanism is carried out. This Tollens reagent. Just I will try to represent that mechanism. Simply you know the oral reaction, you have to practice, that is enough. For it is for only understanding mechanism. Before that, you have to represent various examples for aldehydes and ketones. Take example as formaldehyde. Complete the reaction. Formaldehyde as well. Acetaldehyde. Acetaldehyde. Okay. Now I will represent the reaction. Reaction is said to be, that is R C double bond O and H plus, you can take AgNH3 2 times plus, okay, and there is OH minus. This takes electron because of more electronegative. Definitely it got RC single bond O and this is H and becomes plus. Either again the OH minus, it takes the position of C plus. Now it becomes RCO minus. This is OH and this is H plus. The positive part AgNH3 2 times, that is plus. It takes the position of O minus. Now it becomes RCOAgNH3 2 times and this is H and this is OH. Okay. Now what happens here? This bonded electrons is towards this position and it is eliminated as H plus. It becomes RC double bond O and OH. E bond electrons navilana shift ಮಾಡಬಹುದು. Okay. Yes. And remaining is, this bond is broken. Az plus 2 NH3. Yes, that is enough. Okay. Similar way, there is one important question on this like name reaction, that is also important. What is the use of this Tollens reagent test? Mainly it is used to distinguish between aldehydes and ketones. To distinguish between aldehydes and ketones. Adra ಒಂದು question ಬರ್ತೈತಿ, ketonesಗಳು ಈ Tollens reagent ಜೋಡಿ ರಿಯಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ ಅಂತ question ಬರ್ತೈತಿ. It is difficult, but which type of ketones they are showing Tollens reagent test? They are containing alpha hydroxy group. They are containing alpha hydroxy group, and those carboxylic acids, only one carboxylic acid that shows this Tollens reagent test known as formic acid. Alpha hydroxy, how the alpha hydroxy will be present? This is a ketone, definitely. Now you have to take any of the group. Functional group carbon, next carbon is alpha carbon. Alpha carbon, next it is containing one hydrogen called as, there is a one position, means all are completed. This bond is called, this group is called as alpha hydroxy group. Functional group carbon is ketone, next carbon is alpha carbon. Alpha carbon, next group is said to be OH, that means hydroxy. Such type of ketones they are showing Tollens reagent test. And formic acid, that is H, C double bond O, OH. So this type of formic acid is also showing this Tollens reagent test, because of that hydrogen is said to be eliminated easily and forming the product. Okay, we'll discuss next one, that is said to be another oxidation reaction. That mild oxidizing agent is said to be called as Felling's solution. Felling's solution. There are aldehydes said to be oxidized to carboxylic acid, and what is said to be the Felling solution? Let us, I will continue.